All right, this is function families. So we're looking at the parent functions. So we're gonna go ahead and start with linear. A linear equation looks like f of x equals x. That's the basic function. So let's make an x and y table here. If x were 1, what would y be, right? This is y equals x, same thing. Y equals x. If x is 1, what would y be? X is 1, y would equal 1. They're equal to each other. If x were 2, then y will be 2, right? Because 2 equals 2, 1 equals 1. That's the equation. What about 3? What equals 3? And so on.
The end of second period.
We're just trying random numbers. You can pick small numbers like that, and then you graph it. So we got 0, 0, 1, 1, 1 up 1, 2 over 2 up 2, over 3, 1, 2, 3 up 3, 1, 2, 3, 1, 2, 3. Okay, let's try negative 1, negative 1, negative 1, negative 1, 0, 0, negative 2, negative 2, negative 1, 2, 1, 2. And then take your badge here and draw a straight line. So here, take your badge, and there you go, draw a straight line. Make your arrows, that means that's a line, right? That's why it's called linear, because it's 1 for 1, 2 for 2, 3 for 3. It's a 1 for 1 relationship. Given the parent function, we're graphing. Absolute value, f of x. The equation for this is the absolute value of x. See if you can try an x and y table on your own. Okay, so we've got x and y, right? So, or y equals the absolute value of x, right? For absolute value. So what if x were 1? What is the absolute value of 1? 1. What if x were 0 or 2? The absolute value of 2 is 2. Just the same number. That's it's going to be a positive number. The absolute value of 3 is just 3. The absolute value of 0 is just 0. The absolute value of negative 1 is a positive 1. The absolute value of negative 2 is a positive 2, and so on. So we're going to go ahead and graph it. 0, 0. That's your origin there. 1, 1. 1 up 1. 2 up 2. Looks like a line, right? 3 up 3. Negative 1 up 1. Negative 2 up 2. Negative 3. Oh, what kind of shape do you see? A V. So an absolute value makes a V. So connect your dots with your badge. Go ahead and do that while I do it as well. And you should be making a perfect V. Okay. And then make your arrows because it keeps going and going and going. So that's the parent function for absolute value. Okay, let's look at increasing and decreasing intervals. We're going to use interval notation. So an increasing direction looks like going up to the right. So this function is going up from negative infinity, looking from x to x. So the x going this way, right? Just going up, going towards the right from negative infinity to this number here, which is 1, negative 1, 0, negative 1. So negative infinity to negative 1. And it stops, which is a bracket. Negative infinity, you cannot contain it, so it is a parentheses. Okay, it's constant from here to here. No slope, it's just straight. So from negative 1 to 1, 2, 3, 4 to 4. Those are both closed circles. Okay, go ahead and make your notes that if you see a open circle, it's parentheses. If you see closed, it is a bracket. For increasing, you're looking at the x values. Okay? So negative 1, 4. decreasing from this point to here. 1, 2, 3, 4. That's 4, right? 4 to infinity. So put infinity, positive infinity. From 4 to positive infinity is where it's increasing. That is a closed bracket, right? From 4 to positive infinity. You cannot contain an infinity because it keeps going, so give me a soft parentheses. End behavior. End behavior means, what is the end looking like? This snake so this is as x approaches positive infinity. As x goes right, because it's positive infinity. This is positive infinity. This is negative infinity. As x goes, where does y go? As x goes, where does y go? Okay. So, as x goes right, as a snake goes to the right, it's going down. The y is going down, negative infinity. All right, let's look at this one. As x goes negative infinity, so to the left, as x goes to the left, as a snake goes this way, left, where's it going? Up. You got it, positive infinity. So it's asking you, as x goes left, where's y going? So as a snake goes to the left, it's also going up. It ends up going up because that's your arrow up to positive infinity. This is negative infinity. Let's make sure that you write that down. Negative infinity, positive infinity. Put a positive there. And this is going down, negative infinity. And this is going up, positive infinity. Okay? So that's end behavior. That's your end behavior. Okay? We're going to go ahead and go to the next paper here. Okay, so same thing. We're just going to give more traits here. Linear. What was the equation for linear? You got it. Was f of x equals x. Go ahead and regraph that for me, please. Remember, it was a straight line, right? It was a straight line. So go ahead and give you that straight line. Your domain and range. Domain. Where's the left part of this line? Where's the most left x value? So domain means where's the left part of this line? Where's the right part of this line? Well, the left part, it keeps going. It keeps going to the left forever. It keeps going to the right, up to the right forever. So your domain will be all real numbers, all x values, right? Or you could say negative infinity to positive infinity. You cannot contain infinity, so give me parentheses. Same with range. This arrow is going down, 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 up, 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 down, up. So same thing for your range. All real numbers. X-intercept, well, this is 0, 0. Where does this line cross the x-axis? Write that down. It crosses it at 0. 0. So today we're exploring characteristics, right, of different functions. The y-intercept is where this line crosses the y-axis. This is y, this is x. Well, it's crossing the y also at 0, 0. In behavior, as x goes to the right, so as this line goes to the right, this way it's also going up, right? It's going up to the right. As x goes to the right, positive infinity, right? The y, this means y, f of x, is going also positive infinity for this one. So remember, this is positive infinity. This is negative infinity going down. So make sure you label this positive infinity. Okay, positive, negative, positive, negative. So up, down, right, left. As it goes right, the arrow's going up. I just said no talking, please. I need you guys to listen, please. And then as x goes left, it's going down to the left. As x goes down to the left, right, to the left, it's also going down. As x goes left, it goes down. Increasing intervals. Where does this arrow increase? Well, it increases from negative infinity to positive infinity. These are x values. So it starts on the x-axis way over here, right, all this way. And it goes to the right forever. So your increasing intervals are forever and forever. It also is decreasing. It's decreasing from positive down. From positive infinity to negative infinity. It's going down. Remember, a line is going both ways, right? It's going up and down. It's the same thing. All right. Absolute value. What was that equation? It was f of x equals the absolute value of x. Okay. Go ahead and graph this out on your own. Okay, let's see if you guys can try this on your own. Go ahead and pause the video and see if you can try this one on your own without my help. All right, here we're back. So your domain goes from negative infinity to positive infinity forever. Range. Where is the bottom? So this is left to right. This is bottom to top. Make sure you do your arrows. Where's the bottom of this V? Does this V go way down here? No, it stops right here, right? So that's where it starts. It starts at 0, right? Y at 0. This is 0. 1, 2, 3, 4, 5, 6, 7. So 0 is the bottom. And above. So you can do above 0. Y is above 0. All the Y values above 0. You might also say from 0 to positive infinity. It starts exactly at 0. So make sure that's a bracket. You cannot contain infinity. Okay, from there, your x-intercept is the same as this one. It intercepts at 0, 0 for the x-axis, and y-intercept also at 0, 0. And behavior, okay? As x goes up, y goes up. As x goes left, y also goes up. Increasing, so it increases from 0 to positive infinity. 0 with the bracket to positive infinity. You cannot contain it. And then to the left, it decreases. These are all x values, remember that? So write that down. From 0 to the left, so negative infinity. Or we could say it's from left to right. So write that down. Intervals means left to right. So it's going from negative infinity to 0. So negative infinity to this 0 here. This is negative 1, negative 2, negative 3, negative 4. All right, so we're going from here to here is where it's decreasing. So negative infinity right up to 0. Okay. Quadratic looks like this. It's a square. See if you can give me an XY table for this without my help. And then cubic would be, what do you think cube means? You got it, 3x cubed, okay? Try this one by yourself. It's similar to this one. Make me an XY table. Plug an x value into x, a y value, and an x value like 1 or 0 or 2, and give me a y value. And let's see what shape you make. So that's parent functions.